What do we get? What do we get? There we go. Looks like the loss goes down steadily, which is a good sign, no issues. It doesn't do the steep kind of drop thing like the old one did, which is means it's probably learning slower, which is interesting. And yeah, let's see what is going on with our debugger. So at step 0, we've got this, and then it looks like it kind of works, so that's a good sign. I think we see, yeah, I mean, it's training. I think it's training worse is what I'm kind of surprised about. Let me see. I think this was the last baseline. Yeah, this is 200 steps. These are both 200 steps, and this one ends at 0.07, and this one ends at 0.07, so they end about the same, but it does go down slower. And so, yeah, I can see, yeah, interesting. So I think my guess, if we go back to step 0, we can see on this one you have a nice random splattering of colors, and on this one, if we go to step 0, we see it's not random colors. The background's all teal, and then the foreground's all this kind of gray. And so my guess, so if we look at this one, the feature PCA, this is the feature thing I was talking about, where it's, well, what are the features of the image? And so we have these really cool features that are rich, and this is at the end step, and so we can see like it does kind of some sort of dog shape in the middle, some sort of sky feature, some sort of building feature. But if we look at the first step, I think what happens is we have a strong initialization of randomness of the feature space. However, by the time it makes it to color space, all of the randomness is gone. And so I think this is why it slows down in the beginning, because it basically, that thing I told you I fixed, where I took a benchmark and I was like, make sure our initialization has a bunch of random color that's well spread out on the first step, is gone now, because it gets a bunch of random features, but it does not get a bunch of random color. And so I think that's probably why it struggles to learn, if I had to guess. Let me see by step. You know, pretty quickly it does start to learn something, and so that's encouraging. And I'm sure if we let it go longer, it may actually go lower than the other run, so it might struggle to learn it quickly, but then eventually overtake it. But I want to fix that. I think that would be fun to fix. And let's see, I think we maybe logged a PCA video. I want to check if that's in here or not. GT video. Okay, let's tell Claude. Hey Claude, we ran the baseline and it works. There is 2 things that we're kind of worried about, and the first thing is it looks like the initialization at step 0 of the frames for features is quite rich and has large variance. However, the initialization of color on the first frame is poor, and all of the colors are spread to gray. And so we already have benchmarks for measuring initialization, and the initialization it measures via splats and sees what's the initialized splat range. I think we need to do something similar where we measure not just the variance in features, but the variance in the color output on the MLP from the features. And so it looks like the MLP basically just squashes everything to gray or teal background, which kind of sucks. And so I think that we need to dig into the math of the MLP and see, first we want to write a benchmark that'll give us metrics. So look at our old benchmarks around having high variance of colors on initialization, and then adapt that so that it works on the feature code. So we don't just check the initialization of features being random, but we check the variance of colors after the MLP is applied being random, so we can start to benchmark this in a tight loop. And then also propose 3 hypotheses on what did and didn't work there. So why did the MLP crush everything to gray, and some hypotheses on is there a better way to initialize the MLP so that it doesn't basically flatten the colors? Because the input to the MLP is nice, but its output ends up flattening everything. I think it kind of makes sense everything will go to gray, because you're taking like this really noisy 11 vector thing and putting it down to 3. And so the default for something like that is probably not randomness, but it's probably like an averaging. And so, yeah, we'll have to take a look at that color MLP and see what it is. So I just talked a bunch to Claude, and we're going to dump that text in. So it kind of knows what to do. And it's cool that I talked about the initialization and the benchmarks for it, and it happened to be an issue with initialization on the feature stuff. So we're going to give it that to think. It's going to take a while. And while that's running, let's see what Codex did. Feature dim is ignored by the free Gaussian bank variance. Always applies. So we did run the baseline and it converged. I'm kind of surprised because it seems like you're saying it shouldn't work given number 1. How bad is number 1? Oops, I didn't have the right window selected. That was supposed to be speech to text. So, hey, Codex, it seems like you're saying it shouldn't work almost, like the number 1 seems really bad, but we did a run and it actually does converge. And we used fastmac. And then what about PCA visualization? You're saying it's not stable across log events. I think that's okay. You're just saying we run a different PCA per step, basically, and if so, that's fine. But one thing I did want to fix about the PCA stuff is it seems like we're only rendering PCA on a single frame. I wanted to run PCA across the entire video of all the frames, and then I wanted to log a video of feature frames that are visualized via PCA. So can we kick off 2 agents, and then the first agent should explain a bit more about what exactly is wrong with all of these different things you're describing, because it did converge, it did render PCA frames that look decent. So maybe if there's some flaws, they're not catastrophic. The one thing I did notice is that at step 0, the initialization of the color was not random. The features were random, but the color all squashes to gray. So maybe that has something to do with number 3, which is the X to X sigmoid, if sigmoid is crushing things to gray. And yeah, please use 2 sub-agents, and one of them should go ahead and implement the full video PCA, and the other one should give us a more comprehensive description of all the bugs you found that addresses pseudocode that shows the issue and suggests what the fix should be, and then follows up with some TLDR human style about like, are these actually destroying it? Are they making training not work at all? Are they making initialization poor so that it learns slower, et cetera, et cetera? What's the scale impact of these as well?